Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. We'd like to thank Code for sponsoring our live streams and podcasts from the Software Circus in Amsterdam. Code is a team of passionate open source engineers and advocates building community through contribution and engagement in emerging technologies. According to thecodeteam.com, it's not just a bunch of pillows and stuff we say. It's the core fundamental of what we believe open source provides. That's what drives the Code Team. To learn more about the Code Team again at thecodeteam.com. We caught up with Andy Repton of Schuberg Philis at the recent Software Circus conference in Amsterdam. Andy describes himself on Twitter as an adventurer traveler, mission-critical engineer, and space nerd. He loves playing with Kubernetes, genome sequencing, HPC on cloud, and machine learning. And that's at the moment. Andy Repton, thanks for joining us on this episode of the New Stack Makers. And I'm here with Andy, and Andy is with Schuberg Philis. He's lead engineer there for Kubernetes work in Schuberg.
Yeah, I'm the lead engineer for what we're calling Mission Critical Container Hub, which is our version of Mission Critical Kubernetes. Schuberg Philis guarantees 100% uptime for its customers, so we had to take the very, very powerful and mature Kubernetes and actually make it 100% for our customers and our customers.
Okay, so Andy, sorry, what's your full name?
Andy Repton.
Okay, so Andy, tell us about the journey that you followed to get here. What was the infrastructure you were starting with when you were first beginning this one?
So we have these two really interesting and diverging use cases. We had a group of developers who were starting working with Schuberg Philis and building their code and really struggling to get that code all the way through to production in our cloud. Schuberg Philis runs its own private cloud across multiple data centers around the Amsterdam area. And the actual act of setting up things like VPCs and setting up virtual machines and config management, for small Java web apps or Python web apps, things like that, it was just too much extra overhead of knowledge that they needed to learn. So we were looking for a way to empower these developers and give them access to technology where they could develop on their laptops and push it through to production and be in total control themselves. Obviously, as part of that, containerization came up, and then from containerization, we obviously wanted to look for a good orchestration tool that could then, orchestrate those containers in a way that keeps us available, keeps us up, and everything like that. And we investigated a couple of different technologies back then. The first one was Mesos Marathon. Then we looked into Docker Swarm for a little bit. At the time, I think it was Compose. And then we came across Kubernetes, and we just found that the simplicity and the elegance of the tool, combined with the really incredible open source community and the real big enterprise partners who had put their backing behind the project, meant that we really felt that this was a project that could actually take us forward for the next 5 years or so.
So Schuberg Philis is a consulting organization, correct?
Not quite. We're a managed services provider. So what we do is we identify with our customers the mission-critical aspects of their application landscape. We take complete ownership of that, and then we build self-steering teams. We don't have any managers at Schuberg Philis, so we have teams of experts, and they are responsible for the entirety of this mission-critical application that we've taken on.
Okay, great. So your infrastructure itself, I expect, was it, the pre-existing infrastructure was a virtualized infrastructure? Is it still virtualized, or are you running Kubernetes on top of virtualized infrastructure, or are you going to bare metal?
We're doing a bit of both. We had a very virtualized infrastructure, but we very much primarily focus on hybrid cloud strategies. So, if we have a customer who is running a very large Oracle database, maybe it doesn't make sense to virtualize that right now. But at the same time, in front of that Oracle database could be a scalable web app. Well, that's an excellent thing that could be put in containers. And so what we'll usually do is what we're doing right now is we're running Kubernetes on top of a virtualized platform, which is Cloudstack. And from there, we then connect those through using networking. We use software-defined networking to then connect it through to the legacy infrastructure.
Cloudstack is the open source project.
That's correct. We've actually forked Cloudstack. Originally, we were the most active member in the Cloudstack community in terms of code contributions. But what we found was that Cloudstack was taking too long. in its release cycles. We were only releasing about twice a year, and we needed to innovate faster, and so we actually forked Cloudstack. We kept it open source. It's still available on our organization, and we run this for all of our mission-critical workloads with Kubernetes on top of that. At the same time, we are experimenting with bare metal Kubernetes. We're interested to see whether or not we can gain additional efficiencies by running directly on hardware.
Directly on the hardware, so is that your own hardware?
Yeah, that's correct. So we have quite a large amount of servers within our own data centers, so we can actually repurpose a few of them to do testing to investigate efficiency bonuses.
What are you finding is the difference in efficiencies between the virtualized infrastructure and the bare metal? It must be significant.
The main efficiencies are not from the CPU itself. It's more that you're cutting out all the overhead of like the operating system in between and things like that. That being said, virtualized infrastructure does give you some benefits in terms of like lifecycle management. When you're running Kubernetes bare metal, Docker on the host, doing upgrades, all of a sudden you kind of get back to the whole problem of doing upgrades in the first place. And a lot of the benefits that we had with virtual machines, where instead of upgrading, we could just delete the virtual machines, spin up new ones with the newer versions of the software that we wanted, that kind of goes away again. We had to do kind of older upgrades. So we're still investigating that. We're not quite sure where we're going to go at the moment.
So big, a big reason for moving to an infrastructure like Kubernetes is the need to move faster, and to build faster and make things faster, and and achieve new business objectives faster. Tell us about the continuous integration, continuous development process you've been developing, through this project.
So we use a combination of both Jenkins and GitLab CI. So GitLab CI makes it really easy to run Kubernetes GitLab CI when it's inside our clusters, and that really enables and empowers our developers to actually speed up and move faster. While Kubernetes does allow you the ability to drop in new deploy faster and things like that, what we've really seen is the actual efficiency improvements are how we've empowered our developers to move faster. So they use things like GitLab CI continuous pipelines. We also have Jenkins jobs that automatically deploy into the clusters. We have certain development teams who, in order to speed up their workflow, they will run the CI/CD pipeline from their laptops, actually deploying directly into Kubernetes, port forwarding everything back so it appears to be on their own laptops, and then they can actually run the CI/CD locally, and then they can actually do their testing without having, the need to have a laptop with 32 gigs of RAM, sitting there with them. And that empowerment and enablement for the developers to be in total control, that's what's really sped us up.
So with that, development and, what's come of your networking and storage needs, and is that changing, and how are you considering the transformation of those really core environments as you're thinking more about building out both stateless and stateful service environments?
So I'll take those one at a time. For networking, what we've noticed is there's a huge explosion in overlay technologies coming out, and a lot of them are very, very powerful, but they also are at times needlessly complex. And so what we've actually done is we've fallen back on our existing SDN infrastructure, because we don't want to be putting overlays on top of overlays, because that just leads to overhead and actually slowing us down, which we don't really want. In terms of storage, though, what we've noticed is that when you see the big cloud players like Google and Azure and AWS, creating things like elastic block storage or the equivalent, and being able to attach those as a volume API inside Kubernetes is really, really powerful. But because we're on private cloud, we don't actually have synchronous block storage available to us. So what we've noticed is that when you actually remove that dependency on a POSIX compliant file system, what we find is that our greenfield development opportunities actually design around that, and they actually start designing applications that are replicating at the application layer rather than relying on an underlying file system to provide that resiliency for them. And as part of that, we've seen a big move towards things like object stores for persistency. We've seen a big move to things like etcd for distributed key value stores, Galera clusters for MySQL rather than the old MySQL replication stuff. And developers actually actively thinking about how can I design my application in such a way that it will scale nicely, and it will be stateless, and it will continue running even if it gets restarted.
Interesting. So how are you looking to the open source community for, continuing developing your platform?
well, we're very much in tune with the open source community, and we find it very important to give back. It's a real kind of a very important theme of Schuberg. It's one of the things we feel very strongly about. We spend a lot of times at conferences like this, making sure we're sharing information, making sure we're learning from the open source community, and trying to actively talk about the challenges that we face. We actually go and talk at conferences about some of the things that we've built. One of the main things that we built quite a long time ago was actually Kubernetes on Kubernetes. We actually use another Kubernetes cluster to manage our master components of all the others, and open sourcing that and trying to push it out and see whether or not we can actually contribute back to the open source community.
So what's your goals for the next 6 to 12 months then with your Kubernetes infrastructure?
The main thing at the moment is we have a very stable Kubernetes infrastructure at this point. What we're now trying to do is work with the community and identify the best practices on how to convert some of our more legacy web apps and move them into Kubernetes in a best practice manner. We're very much focused on also security, policy, making sure that we can have multi-tenant Kubernetes that allows for multiple teams using the same cluster without the overhead of additional masters. Without actually interfering with one another.
Well, Andy, thank you very much for taking some time to talk with us here at the Software Circus.
Thank you for having me. Thanks so much.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.